welcome back to the P6 Science class with Miss Russ. Ta-da! Okay, so today we are going to continue our revision on PSLE questions. Okay, so we have selected the topics that are very popular, commonly tested, and also quite tricky in some cases. So these three topics, okay, forces, energy, and cells. If you have tried your PSLE past year papers, right, you will see that these questions do come out quite often. And then for those, if you remember from last week's lesson, we talked about experiment based questions, right? Experimental data. Yes, this type of questions love to use this topic, okay? Forces, energy, and cells. All right, so hopefully by the end of today, okay, you'll be more confident to answer this type of questions because I can assure you, if you remember the steps, all right, it'll be very, very easy. Now, last week, okay, for those who are here, I mentioned that there is this method called CER. Can somebody tell me what does CER stand for? Right, so there's this C stands for claim, evidence, and reasoning. Good. Okay, so for those who are still nervous, okay, we will do more practice on this. Okay, so don't worry about it. Right, because I remember somebody say, I never learned this in school, teacher. So can I still use this in my PSLE? Yes, you can try. Okay, later on I will tell you more about it. Right? Moving on. First bubble question. So today is a lot of questions, right? Both MCQ and structured. So don't worry, I will guide you along. And then what we will do first is to try and recall all the important concepts as we go along the question. Okay, so for example, Ricky placed a book on a wooden plank. So let me just highlight all the keywords first. Okay, wooden plank, as shown in diagram 1. He raised the wooden plank till the book starts to slide down. Okay, so book sliding down, and then he measured the angle of the plank. All right, so first things first, what do you think this topic, this question is testing on? Frictional force, right? Because we're talking about having a book placed on a plank and then it's sliding down. So there is a force that is opposing this movement of the book. And that force is called the frictional force. And also another type of force, yes, like what Nathaniel and Justina mentioned, gravitational force as well, because the reason why the book can slide down is because it's going along the gravitational pull. And if you remember, gravitational pull is the pull that pull every object towards where? From the earth middle, from the center of the earth, right? So Kaylin got that right. So it's the gravitational pull that pulls all objects. That's why we are not floating around on earth. Okay, so now let's look at the other clues that they provide in the question. It says that, oh yeah, we have 3 different planks. And what happens is at different angles, okay, the book starts to slide down. So for example, this is the floor, okay, this is the straight floor, and then I put the plank like that, okay, so I can make it flat. I can raise it up. I can raise it all the way up. So when I raise it up to 20 degrees, okay, the book starts to slide down for plank A. And then for B is at 70 degrees. And then for C is at 50 degrees. So think about it. What is that relationship between the surface of the wooden plank and the angle? So are you ready to see the actual question? Yes, for those who have did it, okay, try to remember how to solve this question. Yes. Okay, so this is the question given. They give you 4 sets of graph. You're supposed to interpret the data and then feed it into the graph that is provided. So let's look at the points. Okay, about more than half of you got it correct, but there's also like a few of you who couldn't get it correct. Why is the answer 2? So, right, so some of you mentioned 1, right? Why do you think it's 1 and not 2? All right, so now the difference between these two, I think you can understand why it is placed as BCA, right? Okay, B being the one with the highest friction because it takes it an angle of like 70 before the book starts to slide down. So that means this one should be the rougher surface. And this one is the smoother surface. This one we all can agree, correct? This part can understand? Yeah, so the direction, the arrangement is always BCA. So the only two options that we see here is between 1 and 2. But why is it that the answer is not 1? They think that there's some frictional force no matter where they put. So this is one of the misconception that some students have. Okay, so let me just clarify this. In my previous class, I think some students are also confused about this. So I'll just address it once and for all. Let's say if you have a flat surface, okay, and then you have the book here. This is my book, okay, being placed on a flat surface. There is no frictional force at all. Okay, some of you may have heard of the term static friction. In this case, actually, it is not applicable. Okay, no matter what type of friction we're talking about, there has to be a force that is placed. Okay, meaning there has to be something that is pushing it, or maybe like, when it is on an angle, the gravitational force is pulling it. Yes. And if there's no force at all, and it is on a flat plank, then there should not be any frictional force. Okay, not even static friction. All right, so this is something that you have to be very careful. Okay, first of all, static friction is not in syllabus, like what some of you mentioned. And then second of all, the explanation for static friction, okay, what you think it is actually not applicable. Okay, it still have to involve some form of force, something like applied force where you push it. Okay, but you will only learn about static friction and kinetic friction when maybe you take physics in upper secondary. Okay, so that's why I don't want to spend time explaining it, because you might get more confused. So just stick to this simplified version. If it is a flat base, okay, flat plank, and there is no one pushing the book, okay, we take it as no friction. Therefore, at the angle of 0, there is 0 frictional force. All right, so I hope you are clear about that, because I'm very worried. Some of you say, oh, at a flat surface got friction. No, there isn't any friction. Okay. All right, so when we are clear, let's move on to the next question. This one is similar, still testing on which type of force, students? Still testing on frictional force and gravitational force. Okay, still the two forces, because we are still talking about things sliding down. So let's read the question together. Hans placed two blocks, A and B, at different positions on a slope. Okay, block B is bigger and heavier than block A. Both are stationary until block A is moved nearer to block B. And then suddenly, when block A is moved nearer to block B starts to move downwards. Do you understand what that means? Okay, so highlight keywords. Okay, block B is bigger and heavier. Okay, that's one clue. Then both are stationary until block A is moved nearer to block B. And when that happens, block B suddenly moves downwards. Wow, so what type of force is that? Yes, Sanjay got that right. Magnetic force. And Ashton mentioned repel. Yes, okay, so jot this down. Right, so when you talk about magnetic force, make this a good habit. Even when you're answering questions in the actual paper, it'll be good to write it down so that you can remind yourself what are the important points. For example, if you know that this is magnetic force, you remember to use the word repulsion or repel, right? So if they can repel means which poles are facing each other? Like poles facing each other. Yes, good. Okay, so let's look at the statement. Read the statement carefully. Magnetic forces is acting on both blocks A and B. Block A has greater gravitational force, and then there's no frictional force. So think about these statements. This question will be another 30 seconds. Right, so what is repel? Repel is when both magnets, okay, and then it move away from each other. That's repel. Okay, so let's see what happened to... Okay, good news is majority still got it correct. Not so good news is some of you are still a bit confused. Wait, some of you said you press something and then something else pop up. Maybe you accidentally pressed the wrong thing. Okay, the correct answer is 1, right? Ding. Okay, so let's look at the statements again. I think for the part A, we agreed that this one is easy, right? Magnetic forces is acting because otherwise they wouldn't repel against each other. Then for statement B, right, it says block A has a greater gravitational force. This one is another topic or concept that a lot of students get it wrong. Okay, why do you think block A has a greater gravitational force? Okay, so many questions, so many of you asking, why is B wrong? Does anybody know? Before I reveal the answer, does anybody know? You said that gravitational force is always the same. If you have to check your textbook again if you're not sure. Okay, the information is there. Actually, gravitational force is mainly affected by mass and a little bit affected by height, but not so significant. Okay, so let me explain to you why, right? So when we talk about gravitational force, we're talking about the Earth's gravity, right? Pulling objects down. So imagine, okay, you have again the flat land, land flat, what am I talking about? Flat land, right? So then you have your block A and block B, this heavier one is bigger in size, right? So the part where you think, you know, some of you said gravity is constant. Okay, it is not referring to the gravitational force. It is it's actually referring to the acceleration or something like the speed of falling down. Okay, and we don't teach that in primary level because it's quite a complex. You need to use it's a complex equation where you need to use like a formula to calculate. And in simple terms, right, it just means that if there's an object on Earth, okay, it will, if you are like dropping it onto the ground, okay, it will accelerate at the almost like similar speed. That's all it means. Okay, so like what I mentioned, it is the part where objects drop down, okay, at the same speed, and that is constant. But when we are talking about mass, okay, all objects on Earth, okay, have different mass, right? So when they have different mass, okay, they will exert different gravitational force. So the higher the mass, okay, the higher the GF or your gravitational force. And this is measured by your weight. That's why different objects have different weight. You see it? Yeah. So the heavier the object, of course, the weight is higher. Okay. And just now I mentioned it can be affected by height, but this is only applicable when you're super far away from the center of the Earth, meaning you're standing on top of Mount Everest. If you're standing on top of Mount Everest, which is one of the tallest or highest peak on Earth, right? Maybe your weight will be slightly lower as compared to when you're on the ground level. But it's very little that usually we don't take it into consideration. Okay, so I hope I made that clear, right? So that's why B is not correct, because by right, due to the mass, okay, block B should have a higher GF. And if you're confused about this term, just remember for objects, gravitational force is measured by their weight. And if the bigger the object, the heavier the object, the higher the weight. And the part about gravity is constant, that is not referring to the gravitational force. All right. It is another term for like part of the calculation for gravity, which you will learn again in secondary school. Yeah, so don't worry about it. If you dig underground, I mean, technically, if you're way close to the center of the Earth, then yes, your gravitational pull will be the strongest. So your weight should be slightly higher. Okay, come, let's move on to the next part. Question 3. Cindy had 2 similar springs. When a 50-gram mass was hung on one spring, she noticed that it extended. Okay, so original length is this much, right? This is the original length. So let's just put it as L. And then after you put 50 grams of mass, okay, it starts to extend. So maybe roughly about 2 times, okay, about 2 times. You can't really tell unless you use a ruler. So we just give a rough estimate. Before we answer the question, what type of force are we looking at right now? ESF, which stands for elastic spring force. Well done. Okay, so look carefully at the options. All right, look carefully at the numbers, right, before you answer the question. Oh, okay. Oh, wow. Majority of you get the correct answer. Great. So yeah, the answer is number 4. For those who didn't get it right, what happened? Oh, you don't like it because it's hard to understand. Oh, don't worry, don't worry. Okay, let's look at the question together. I think the top part here is easy to see, right? Like if 50-gram mass, it was stretched to more than, yes, if you compare this length, let's say this is x, compared to the previous one here, okay, it is slightly longer, right? Is more stretched than this, correct? Why? Why is it more stretched? They said yes, but what's the reason? Because it is carrying the, yes, this is also stretched due to the mass of the bottom weight. Yeah, so in total, right, this x here is being stretched by a total of 80 gram. And then if you look at 30 gram, of course, it has to be, less stretch because it's not as heavy as the 50-gram mass. It is stretching, but not as much. So that's why it's shorter. Okay, and if you look at the other option, like this one, come on, how can it be stretching so much? Doesn't make sense, right? 30 gram, 50 gram, about the same length of stretch? Nah. Okay, don't worry. If you don't get it, okay, just remember, the heavier the mass, the higher the mass, the more the spring will stretch. And if you have 2 mass here, okay, the top most string was the stretch by taking into account the 2 mass, means the total of 80 gram. Okay, next. Let's see, bubble question 4. Ring magnets S and T will slip through a wooden pole as shown in diagram A. Okay, D is the distance between magnet S and T. So we have D over here, which is the distance. And then it said that different masses of load were placed above the magnet S, which is over here, and they measure the distance. All right, easy. What type of force is this? Yes, magnetic force. You just put MF, magnetic force. Okay, let's see, mass of the load. So as you increase the load, the distance, okay, actually decrease. Yep. Okay. So now that we know this information, somebody say, oh, forces of repulsion. Okay, good. Yeah, that's why it stays hovering on top, right? Okay, so read the statement. Which one is definitely true? Okay, so the answer is 3, right? All right, so with increasing mass of load, the greater gravitational force is acting against magnetic force, meaning there is more gravitational force exerted onto the magnet that causes the magnetic force to be lower. Okay, option 4 is wrong because at the point where it is 0, right, and then the magnets S and T are like flat, okay, in contact with each other, does that mean that there's no magnetic force at all? No, okay. Even though they are super close with each other, there is still magnetic force. It's just that it is lower than the gravitational force. It's still present. Okay, unlike poles, oh, no. Because originally it has to be like poles. Otherwise, it wouldn't be separated out like that. It will just be like flat together. Okay, attracted together. Okay. Yeah, so in this case, when it is sandwiched like this, sandwiched together like this, with the mass at the top, there is still magnetic force, but it is smaller than the gravitational force that is exerted downwards. Okay, I hope you get that. Now, back to the CER method. Just now, if I recall, earlier some of you mentioned, teacher, my teacher in school used the word explain. Or what was it? The other word somebody mentioned, reasoning as something else. Actually, the terms are similar. Okay, so some of you said claim, evidence, recall. So it is the same, it's quite similar from, your CER that you're using here and the one that you're using in school. Okay, so at the end of the day, right, you have to use the one that you're comfortable with. Okay, this one I feel that is easy for me or for the students to understand. But if you still want to use the method that your teachers are using and you feel like that's the one that you're more confident in, you can choose to do so, okay? All right, so let's see. The picture below shows a bowling game. Okay, the bowling ball is released before hitting the pins at the end of the lane. So if you have played bowling before, you know that, first of all, the bowling lanes are super slippery. Okay, so you cannot wear any regular shoes to walk on the platform. You have to borrow or rent their bowling shoes. Okay, and the reason is because it's very, very slippery, right? And then if you look at the time taken, there are 3 different surfaces. Time taken, average time for the ball to hit the pins is 10.6 seconds for surface P, and then it's only 4.5 for Q, and then it goes back up to 8.7 for R. Squall found that surface Q allows him to hit the most number of pins. Explain why. So this is the part where you use the claim. Okay, so what is your claim in this case? Let's see who can get this right. Q is the smoother surface. Do the rest of you agree? Renton, Serene, yeah, okay. You got it. It's the smoothest, but you have to fill up the comparison part among the 3 surfaces. Okay, just to make your answer very clear, right? And then what is the evidence? Remember, evidence is looking at the data. So what do you get from the results? How can you tell that this is the surface, the smoother surface? Victoria mentioned average time taken is the least. Do you guys agree? Shortest amount of time. Yes, okay, so the rest of you agreed. Good. Shortest time, okay, to hit the pins on surface Q, because if you look at the time taken, it's only 4.5. And then finally, the reasoning part is the part where you give your final answer. So what is the reason? When it's the smoother surface, means that that is least what? They're fast, yeah, of course they're fast, but how does the smoother surface lead to it moving faster? There is the least amount of friction. Is that complete? Friction between the, okay, Sanjit said, between the ball and the surface. Yes. Okay, always remember, frictional force is between 2 surfaces. So you have to mention which surface you're referring to. Yeah, okay, so this is your final answer. So if you write this answer, right, wow, your marker will be very happy to be like, wow, this student can fill out all the things in. So when you say the reasoning part, basically you combine the claim, the evidence, and then the scientific part, the scientific knowledge, which is the part where you talk about the frictional force. Okay, so surface Q allows him to hit the most number of pins as it is the smoothest surface. This means that there is least amount of friction between surface Q and the ball. Therefore, the ball took the shortest time to hit the pins. Still on the same scenario, but now they changed a bit of information. Okay, which pair of shoes X and Y should Squall wear on the surface Q so that he will not slip? So you look at the surface of the shoe, right? The bottom part, the soles. Notice that X looks like that, and then Y looks like that. So what is the claim? What is the claim? Yes, okay, so shoe Y. How about the evidence? Okay, help each other out so that everyone can get the bubbles. Y has grooves. There are gaps. They have a rough surface. Most grip. Okay, good. You are on the right track. It has a rougher surface, more grooves compared to shoe X. And what's the final reasoning? Nice one. Okay, so see, complete answer. The rough surface increases friction between the soles of shoe Y and surface Q, reducing the chance of slipping and falling. Yay! All right, well done. Okay, so for the time being, okay, let's look at this question. Try it yourself. Vicky performed an experiment on spring Q using the setup shown on the left. Okay, so more questions on spring. And then we look at the results. The mass increases. Oops. Mass increases. And then the compression increases as well, meaning more of the spring gets compressed. Okay. So what does that mean? All right. Identify the forces acting on Vicky as he sat on the rocking horse. Okay, so this spring cue is used as part of the rocking horse. For those who have played in the playground before, you've seen this rocking horse or some other animals that they use, right? Okay, so who can tell me what are the different forces? Yes, gravity. Well done. 3 forces at play. Okay, because gravity, because he is sitting on the spring, so he's exerting gravitational force. Of course, elastic spring force from the spring itself, and then frictional force because it's like moving back and forth. Yeah, there's no magnetic force here. Okay, unfortunately, they didn't use any magnets. Yeah. Now, after he alighted, okay, alighted means get off. Spring Q returned to its original length. Explain the change in length of Q in terms of forces. Okay, so let's fill in the blanks. The wet force exerted by Vicky is no longer compressing the spring. Okay, Chloe said gravity force. Gravitation, yes, Ruth said gravitational force. Yes. Then the spring returns back to its original length. That is the evidence, right? And then finally, without the same thing, gravitational force, the spring Q will return the spring back to its original length. Yeah, guess this one is easy peasy. Okay, we're moving on. Right, so the next part, we are done with forces. So let us move on to energy, which is also another popular topic that is quite commonly tested. Question number 5. Study the classification chart below. There are forms of energy. Okay, so there's energy R, energy S, and then you look at the examples. So then they ask you which of the objects have been incorrectly classified. Wow, what happened to my writing? Hold on. Let me make it neater. Incorrectly classified. Okay, so before you answer this, you must first identify the type of energy, okay, for each, for the R and the S. And then you look at the examples given. Yay! Okay, so for those who did, good. For those who did not, don't worry. Okay, again, like I said, this is our practice, right, before your actual PSLE. So who can tell me what is the energy R representing? Is S kinetic energy? Everybody agree? Yes? Good. Then how about R? Potential energy? Correct. Very good. And under potential energy, right, what are the various types of energy? Who can remember this? There are 3 types of potential energy. GPE, CPE, EPE. What are those for? So you have chemical, gravitational potential, yes. And the last one is elastic potential. In exams, do you need to know this? Like the words itself? No. Okay. Unless you're super confident, you want to include it, they will mark you correct. But if you're not confident, just stick to potential energy. Okay. Chemical potential energy is the one that you can find in food, right? Stored food or like in battery. Yeah. So the answer is 2 because this one should have been KE. And the fruit on the tree branch, it should be, because it's on the tree branch, right? So it's just hanging there. What type of energy is it? Should be, yes, just potential energy, or in more detail, it will be your gravitational potential energy, but we just keep it to PE, okay? Potential energy. All right. Bubble question 6. Jimmy wanted to find out how the mass of an iron ball, it's a mass of iron ball, and the height at which it is dropped onto the steel plate affect the loudness. Oh, wow, this is something new. Okay, so this is your sound energy. He prepared the setup as shown below. Okay, so you have the iron ball here. You drop it onto the steel plate. It'll be like ding, got the sound, right? And then you have a data logger with a sound sensor. Okay, and then this sound sensor attached to it can record the data in the table below. So you see, as you increase the mass of the ball, okay, the loudness increase, but the loudness for the different heights also differ. Okay, so for example, at 10 cm, it's only as such, and then at 20 cm, at 30 cm height. But there is a disclaimer here. He mentioned that this sensor can only measure a maximum of 45 units of sound. So this is the limitation. Okay, sometimes when you're using an instrument, right, it cannot be perfect. So if let's say they say, oh, I can only measure 45 units of sound, anything more, it cannot capture. Okay, so that's what it means. All right, so let's see. Based on Jason's experiment, which of the following statement is true? Yay, for those who get it correct, give yourself a pat. Pat on your shoulder. Well done. Yay. Oh, wow. Okay, not too bad, not too bad. Majority got this correct. The answer is for, okay, a ball that is dropped from a greater height will produce a louder sound than the same ball that is dropped from a lower height. I think we can see this from the data itself, right? So for example, if you compare 10 cm height versus, 30 cm height versus 10 cm height. If you look at the average levels of the sound, okay, the average units of the sound, it is definitely higher, right? So if you look at, let's say, just 1 kg ball, at 30 cm is 32, at 10 cm is only 12 units of sound. So 4 is definitely true. The rest of the option, okay, let's just do the cancellation or the elimination method. The loudness of the sound produced is definitely 45 units when a 3 kg ball is dropped at 30 cm. So this one is referring to here. Do you think that's correct? It's not, right? Because like I mentioned previously, there is a limitation to the use of the sound sensor. So at this point, by right, if you look at the trend, this one should have been higher. But because the sound sensor can only measure up to 45, it cannot give the exact value. So this is wrong. Smaller mass produce louder sound. And a ball with a larger mass drop at greater height will have all of its potential energy converted to sound energy. Wow. You could also be converted to what? What other type of energy once it hit the plate? Yes, heat energy. Yes. Okay, so don't forget, it doesn't mean heat, then you can hear the sound and then that's it, everything converted to sound. No, there will be some heat energy, and if the ball kind of like, you know, slide a little bit against the plate, there might even be some kinetic energy. Yes. All right, next. Try it yourself. Damien arranged some similar blocks as shown on the right. He then pushed only the first block. Okay, so you have the first block, and then the rest of the block fell as well. This one reminds you of that one game, right? What you called it, the dominoes game. Push something and then the whole thing will just drop. Okay, so explain in terms of energy how the last block fell. Which is the option? Which one do you think it will be the best explanation? Do you need me to explain why the answer is 4? Okay, so the reason why 4 is the best answer, right, is because the description is, first of all, it's detailed, and it also helped to link back to the evidence. Okay, remember about the CER? So first of all, it mentioned that there is enough kinetic energy, okay, transferred. When you're pushing and everything fall down, right, there is kinetic energy transferred from the first block all the way to the last block. Okay, so this is the claim, and then the evidence is because first block to last block causing it to fall. All right, so that's why 4th is the best so-called statement as compared to the rest of the statement. Not just because it's the longest statement, but it's because it does fulfill the CER part. Yeah, okay, next question. Damien then replaced the last block with a block that was 3 times heavier. Okay, so this new block is very heavier as compared to the original block. So when the first block was pushed, the rest of the blocks fell, but not the last block. Explain why. Okay, so fill in the blanks. Yep, more kinetic energy is needed to cause the last block to fall. Evidence is because the last block did not fall. Given that the last block is what? Then what kinetic energy? Okay, this one I think is the same one as the claim. Given that the last block is heavier, yeah. So do you see that your reasoning part here is a very complete answer? Oh, very careful. Don't use the word bigger, because if you say bigger, right, it doesn't necessarily mean it's heavier. Something can be big, you know, like a balloon can be big, but it is light. So you have to use the correct term. So in this case, we talk about weight. So we talk about whether something is heavier or lighter. Okay. Next question. All right. Same scenario, but then it said, state 2 changes Damien can do to ensure that the last block falls when the first block is pushed. What can he do to make sure that the last block falls when the first block is pushed? Give a harder push. Yep, harder push. Harder push means more what? Force, right? Greater force. Yeah. Change the blocks to the heavier block. Which one? Which one can you change to the heavier block? Just the first one. Yeah. So you can you just do this. You replace the very first block with, oops, my spelling. Replace the first block with another new block. New heavier block. And that will give the same effect, because now the heavier block, when it falls down, there's more force. Yay, last part. All right, on cells. So let's look at this question together. Marcy carried out an experiment in a dark room as shown on the left. All right, the desk lamp were identical. So dark room is the keyword here. Desk lamps were identical. Distances between the desk lamp and the beaker were kept the same. Okay, 10 cm, 10 cm. Then it is observed that the amount of gas produced, were the same, even though there was an additional water plant in Y. Okay, suggest a reason for the observation. So there are 2 water plants here and only 1 water plant here. Okay, assuming that the amount of light is the same, amount of light, okay, is the same, because distance between the lamp and the plants are the same, and you're using basically the identical lamp, so amount of light is the same. Only difference is setup X has 1 plant, whereas setup Y has 2 plants. So what is the claim? The amount of what in both setups are the same. Before we can answer this question, we have to think back. What is this process testing on? What is the name of this process? Photosynthesis. Okay, photosynthesis, or when the plant make food, right? Synthesis. And what do the plants need when it undergoes photosynthesis? It needs carbon dioxide. Okay, carbon dioxide plus water. And then there's an arrow, give you sugar. And most importantly, for every other living thing, we need oxygen. Good. Okay, and then this is in the presence of light or sunlight, right? So in this case, why do you think the oxygen level, okay, assuming that the gas produced here is the oxygen, why do you think it's the same? Because of the presence of either carbon dioxide or water. If you look at the setup, 1 water plant versus 2 water plants, definitely the one with the 2 water plants will have more chloroplasts, correct? But that doesn't affect, because at the end of the day, even though water plant in Y, there's 2 of them, have more chloroplasts, but the amount of gas collected is still the same. What about light? The amount of light is still the same. So that doesn't change anything. Now, it doesn't explain what is it inside this setup that is preventing the plant from further photosynthesizing. Okay, so yes, so it's either carbon dioxide and water. Between carbon dioxide and water, which one do you think will be a better answer? In real life, carbon dioxide does have a more significant impact on the rate of photosynthesis. So in this case, this one is the amount of carbon dioxide in both setups are the same. That's the claim, okay? And the evidence is because at the end of the experiment, you notice that plants in both setups produce the same amount of oxygen. So when you bring in the reasoning, okay, you have to talk about the process of photosynthesis itself. Okay, how does that lead to the same amount of oxygen. So read the statement carefully. Plants in both setups receive the same amount of carbon dioxide during photosynthesis. Okay, thus both plants produce the same amount of oxygen. So no matter how many plants you put in there, but the amount of carbon dioxide given to them is the same in both setups, it will not allow the plant to photosynthesize more. It will photosynthesize at the same rate. All right, so we're going to move on to the next question. This one, all right, let's see. This is under cells. Okay, so you have C, D, and F under the microscope, and Serene drew it how it is shown. Okay, so the question asking is, which one is or are animal cells? Explain your answer. Okay, what do you think will be the claim? Cell F, yes. What is the evidence? There is no chloroplast. No, wait, no cell wall. Okay, no cell wall. Right, and what is the reasoning? If it's no cell wall, then how can you tell that it's an animal cell? Because yeah, it has no cell wall, but what's the reason? How can you say that if something like if a cell doesn't have a cell wall, it's an animal cell? Because only, Celeste is correct. Only plant cells have cell walls, and this is true for all plant cells. Even the special types of plant cells, they all have cell walls. Okay, so you can write it down this way. You can say that cell F does not have a cell wall. That's your claim. And then your evidence is, since all plant cells have cell wall, okay, cell F is an animal cell. Can you write chloroplast? Eva mentioned chloroplast. How about the rest? Do you think chloroplast can be the answer instead of cell wall? No, because not all types of plant cells contain chloroplast. Example of plant cell that does not contain chloroplast, root cells. Yes, so this one, be very careful. Not all plant cells contain chloroplast, so you cannot use that as a measure, simply because like we mentioned just now, example, root cells, okay, they do not have chloroplast. How about stem cells? Okay, very easy. If you see that the color is green, most of the time it should have a bit of chloroplast. If it's very, very dark green, then more chloroplast. But if you look at the roots, they are not green in color. Okay, so these are our final words for you. Stay calm and focus. Do a proper time management. Do not rush. Okay, if you find some questions are very, very difficult to answer, okay, you can skip and try again later. And again, have a proper rest, proper meals before you go for your PSLE paper. All right.